So what if you started with a differential equation like dy dx equals negative x over y? And let's just look at the slope field for that. So the first thing to notice is that if y equals 0, the derivative is not defined. So everywhere where y equals 0, which is all of these points right here, we are going to leave the slope field blank. We're not going to draw in little slopes. So I'm going to go point by point for a little bit here, and let's say at this point right here, x is 0, y is 1. Well, if x is 0 and y is not 0, then I know that I'm going to have a slope of 0. So I'm going to have a slope of 0 right here, and right here, and right here. If I take this point right here, 1, 1, then 1 over 1 is a positive 1, but I have my negative in front, so I'm going to give it a slope of negative 1. And I'm going to go check. I know that this I can't draw. I come down here to this point, 1, negative 1. Well, 1 divided by negative 1 is a negative 1, but I've got a negative in front of it, so this one will be positive. For this point right here, negative 1, that makes 1, 2, 3 negative, so that makes it a negative 1. For this point, the x is negative, the y is positive, and I have another negative, so that's 2 negatives, and I've got a slope of 1. So the next point I'm going to look at is 2, 1. So it'll be negative 2 over a positive 1 is a slope of negative 2, so it's going to be steeper. Whereas this point, the x is 1, the y is 2, so it's going to be shallower, a 1/2, but it's negative. This point right here, this is 2 to the right and 1 down. So it's a positive 2, a negative y, and another negative makes it positive, and it's a positive 2, so steeper. This point is x equals 1, y equals negative 2, so a 1 over a negative 2, but it's negative, so it'll be a positive shallow line. And it looks to me like I'm getting circles in this. I can go along and check, but I'm going to notice right away that in this quadrant, the x's are negative, the y's are positive, and then I have another negative, so these should all have a positive slope. As I go up, my x values are getting bigger, my y values are getting bigger, so the whole fraction should be getting smaller and it's going to get more shallow. Over here, the same thing's going to happen, but the slope has the opposite sign, so more shallow. On these, the x values are 2, negative 2, and it's a y value of a negative 1, that'll make it a negative 2 steeper slope. And this one will have a positive 2 steeper slope. So at this point, I'm pretty sure that I'm getting circles in. I can check this. The 2 and the 2 is going to give me a negative 1 slope and positive over here. So this is just the beginnings of the slope field, and you can see why the slopes are undefined here. We would have vertical tangent lines. So let's suppose that we actually wanted to find the general solution of this differential equation. I would hope that I would get a circle or something similar. So to do that, we're going to use separation of variables. So I'm going to take the y, and it needs to go to the left, so I'm going to multiply by a y. I'm going to take the dx and move it to the right. So I have y dy equals negative x dx, and I'm integrating both sides. I can just do the power rule for these, so it's going to be y squared divided by the 2 equals a negative, and then the x will be squared divided by that plus c. I need to solve this differential equation, so I'm going to multiply both sides by a 2. So I have y squared equals a negative x squared plus c. If I keep going, I'm going to have y equals plus or minus the square root of a negative x squared plus c. And let's just go back up one step right here. If I take the x squared and move it to the other side, I have x squared becomes positive plus y squared equals c. This is the equation of a circle. This c is r squared, if we look at that. If you don't happen to catch it there, it's okay. If you're actually given solutions, you'll be plugging numbers in here and figuring it out. You often see it written as r squared minus x squared underneath the square root when you see a semicircle. The positive version, the positive square root, is the upper half, and the negative version is the lower half. So the positive gives you the top half of the semicircle, and the negative gives you the bottom half, because this is where your y values are positive, this is where your y values are negative. So it is a circle, and everything's working out the way it looks like it should. So the next thing that they could actually ask for, someone could ask for, is, okay, this is the general solution to this differential equation. What if I want a particular solution? So a particular solution will give you the equation of one of the circles. So let's say that we want the particular solution that satisfies the condition that, let's see, it's going to pass through the point x is 2 and y is negative 1. They can say it's when x equals 2, y is negative 1. They can say with these conditions. In some way they'll say this, but what that means is we have a point, we can plug it into this equation and lets us solve for c. So I'm going to pretend I don't know about this equation here for a second, and I'm just going to work with this one. So what you need to notice is my y value is negative. So if I try to say, well, y equals the square root of my negative 2 squared plus c, I'm taking this in, then I would get the square root of negative 4 plus c, and I'm plugging into my y value a negative 1. You should notice that you have a problem. You have a negative value equaling a square root. If you don't notice and you keep going, okay, I'm going to square both sides. So 1 equals a negative 4 plus c, so c equals 5. Everything seems normal and okay, but this is the top half of your semicircle. It is not the bottom half of your semicircle. So what you should start with is my y value of negative 1 equals, and you know you've got the square root of a 2 going on, so negative 2, and you're putting the 2 inside the square, squared plus c. You should catch it right here. You cannot have a negative answer if you don't put the negative in front of the square root. This just doesn't really work. I can put c back in here, and it's not going to work. It's not going to give me a negative y value, but this will. So negative 1 equals the opposite of the square root of negative 4 plus c. So I'll multiply both sides by 1, and 1 equals the square root of negative 4 plus c. Everything's fine. I've got my 1 squared is 1 equals the square root of negative 4 plus c squared, and 1 equals negative 4 plus c. c equals 5, but you figured this out. So I'm hoping y'all will catch that earlier rather than later. So I would write my equation as y equals the negative square root of a negative x squared plus 5. Well, let's say you didn't, okay? Checking your answers should give you the right result, because let's say that I didn't catch that the negative belonged right there. So I thought my equation was y equals the square root of negative x squared plus 5. Let's just check. Plug your point in. 2, negative 1. It should work, right? Because this is the solution. So negative 1 equals the square root of a negative 2 squared plus 5. So negative 1 equals the square root of, this is a negative 4 plus 5 is 1. Hopefully right now you catch that it did not work. So this is the only solution to the differential equation. Now it's only going to give you the semicircle. This will just give you the bottom half of the semicircle, but when we draw solutions, we don't really draw through where the function is undefined here. I'm looking for a function. Okay, so this is y equals. If I want the circle, that's pretty easy to do. Okay, so this is my r squared, right here. So I could say the whole solution is x squared plus y squared equals 5. And that's going to give it to me. That'll give me the equation of the circle. If I want the function, then I'm going through this one, the function that passes through this point. So it really just depends on what you're looking for. When you're solving differential equations, they'll often tell you, like if they hadn't given you a point, they could have said, to get you to the same exact answer, they could have said y is less than equal to 0. If they wanted the top semicircle, then you would say y is greater than equal to 0, and that would work. But there's a lot going on with this one problem, but it's our first look of what do you have if they actually give you a condition, and I'm going to call it an initial condition. They're saying it's going through that point. What that means is you no longer just have a c in your equation, but you can solve for your c. So you've got one particular solution. It's over 2 down 1. I've got the semicircle that is going to go through that point, and it's a horrible drawing of a semicircle, but that's it. The whole circle would go all the way around.